Hi there. We talked today in class about scatter plots and trend lines, so this is a little mini lesson covering the material that we looked at today. This table shows the gallons of gas purchased compared to dollars spent. So for example, when 1 gallon was purchased, we spent $1.50, or 2 gallons was purchased, we spent $3, etc. And the first topic covered was building a scatter plot. A scatter plot is just taking each of these data points and plotting them on a graph. So I have here a graph pre-prepped, and I have counted or scaled by 0.5, 5/10. So my x-axis down here is gallons purchased, and my y-axis is dollars spent. So my first point is $1.50, so I'm going to go right to 1 up to $1.50. And then we have 2, $3, 3, $5, and so forth. Through 8 gallons, $13.50. And then the second topic that we looked at was correlation. When we're looking at a graph, correlation is similar to slope in that if you have a positive correlation in your points, the general route that they take is going to be in a positive direction, right? It's going to be an incline. If you had a negative correlation, there would be a decline. And so I have a picture of that on the back here. Okay, so again, positive correlation, these points ascend. Negative correlation, the points descend. And no correlation, they are scattered all over the place. In terms of the real world, a positive correlation happens as one variable increases and the other does. For example, if you were calculating the amount of ice cream sold compared to temperature, as temperatures outside raise, right, we're entering the 80s and then the 90s and then the 100s, the amount of ice cream purchased would also go up, right? And then the amount of ice cream sold would go up, because people are going to buy more ice cream when it's hotter outside. Negative correlation occurs as one variable increases and the other decreases. They have a negative reaction on each other. Using a similar example, as the temperature goes up outside, the number of coats that are sold goes down, because people don't need coats, it's hot. Okay. No correlation would be when there's no connection to the two of them. For example, as the temperature outside goes up, the letter in my name starts with a D, right? Something like that, where there's no relationship. The number of letters in my name compared to my weight, for example, right? That doesn't have any effect. Okay? There's no relationship between the two of them. So when I'm looking at this graph, I see that there's definitely a positive correlation, because it's ascending. Okay, the next topic, or next item of conversation, was the trend line, or a line of best fit. A line of best fit, or a trend line, is one that would go through about the middle of that data, connecting, theoretically, 2 points, in a way where you would have about equal numbers below as you did above. Right? We want to go pretty darn close to the middle of that line. Okay? So when I'm looking at this, if I connected these last 2 points, this would not be a line of best fit, because if I made that line, I would have 1, 2, 3, 4, 5 lines below, or 5 points below, I should say. Okay, so I'm going to go ahead and rotate that down. I'm going to try to see if I can find a different line of best fit. Well, if I connected that last point And the second to last point, well, it's getting closer. I have 1 above, but I still have 4 below, and I feel like I could probably do better. So I said, well, what if I got rid of this last point and stopped trying to use it? And what if I used that second point and maybe, or second to last, I should say, second to last point and maybe that third point? And I see that gets a lot closer because, yeah, I definitely still have 1 below, but I see I have the other 4. It goes pretty close through the middle of them and then 1 above. And so I'm probably going to pick that one. I'm going to do the third point right here to the second to last one as my line of best fit. And I noticed, sure enough, I still have this 1 that's below up here, but I also have 1 above, and the other 3, it's pretty close through the middle. And so that's my line of best fit. Okay, so then the next topic of conversation was how to write the equation of that line, y equals mx plus b. Just a reminder, m is our slope, and slope is found by doing the change in y divided by the change in x, or rise over run, if you prefer. And so when we're looking at the 2 points, I chose my third one, which was the point 3, 5, and my second to last one, which is the point 7, 13. And so I'm looking here, what's my rise and my run? Rise, change in y. So how did I get from 5 to 13? Well, 5 to 13 is plus 8. And so my rise is going to be positive 8. My run, change in x, 3 to 7, is plus 4. And so my run is going to be 4. And then you can either leave it as a ratio, or frankly that simplifies to a pretty nice number. 8 divided by 4 is 2. Okay, so we have y equals 2, which is my m, x plus b. I still don't know b. Okay. To find b, I'm going to use either one of these points because they were both used to actually draw in the line. I'm going to go ahead and use the 3, 5 one simply because they're smaller numbers, but again, either one would work. So the 5 goes into my y, and the 3 goes into my x, and I'm going to solve for b. So 2 times 3 is 6. Subtract the 6 over, and we get b equals -1. And so my final equation, y equals, my m was 2, and my b is -1. And if I look on my graph, it looks like my line is probably going to intersect my y-axis around -1, but I would not recommend using that as your gauge. I would always calculate it algebraically. The reason is we're constructing this graph by hand. There's a lot of things that could go wrong, right? You know, if I hadn't scaled by 0.5, I might have been guessing, you know, where is 13.5? It's probably around the middle of the square. Well, what if I was a little bit too high or a little bit too low, right? What if my ruler slipped as I was connecting these 2 points, and that would skew my line just a little bit, either too high or too low? Again, changing my y-intercept potentially. So don't use your graph to find your b. Okay, it's not necessarily going to be accurate. Like I said, lots of potential places for inaccuracies. Okay. The second to last topic that we covered was what I call plug and chug. What if you were asked a question like, how much money would you expect to spend to purchase 10 gallons? How much money would you expect to spend to purchase 10 gallons? Because we have this nice equation now. It comes from our line of best fit, and this line of best fit is modeling the trend we see in this data. And so I can use that model, y equals 2x minus 1, to calculate this. Y equals 2 but my x is going to be 10. And this is why I call it a plug and chug, because it really is a computational step. If you have complicated numbers and need to utilize a calculator, please feel free to do so. And this one we can do by hand pretty easily. 2 times 10 is 20 minus 1, which is 19. And so I would expect to spend about $19. The final one is our correlation coefficient. So I'm going to go ahead and turn this over and zoom back in. Our correlation coefficient is designed to measure the relative strength of something. Right? So if we were looking, for example, at a graph that looked like this one. And when I say strength, I mean how close to a perfectly straight line is it? This graph is really close to a straight line, and so that's going to mean something when it comes to a correlation coefficient. So our correlation coefficient we call R. And when R is close to -1, this is a strong negative correlation. And then there's a spectrum of numbers, and as it gets closer and closer and closer to 0, at 0 there is no correlation. And then as it gets closer and closer and closer to 1, this is a strong positive. So what does that mean for this graph? Well, since this is pretty close to a straight line and it's going in the positive direction, I know my R is going to be pretty close to 1. So if I were given a couple of R's, like R equals -0.3, R equals -0.98, R equals 0.2, R equals 0.89. I'm going to be looking at which one of these would be close to 1, because that's fairly strong. It's obviously not negative, because it's not a negative correlation at all. But 0.2 is closer to 0, and that would look more scattered. And so it's not 0.2. R equals 0.89 is close, and so that would be a strong positive correlation. Similarly, if I gave you this graph, and when you're looking at this, you can see there is a negative correlation. There's definitely a decrease that you can see here, but it's not very strong, right? This is very scattered. It starts to look pretty close to no correlation. And so if I gave you some R's, like such, we're going to be looking for, well, which one of these is negative, because it's a negative correlation, it's decreasing, but isn't that close to 1, because that's not close to being a perfectly straight line. So we're going to go ahead and cross off 0.1 and 0.9, because those aren't negative. But then between -0.2 and -0.9 is definitely really close to -1, which would imply it was close to being a perfectly straight negative sloped line. So our R here is going to be -0.2. And that was our lesson today.